So the next thing we're going to discuss is our derivatives for logs and exponents, but when I have other bases other than e. So if I take the derivative of a to the x, this derivative will be ln of a to the x, and a needs to be bigger than 0. And the derivative of log base a of x will be 1 over ln a times x. And again, a needs to be 0, bigger than 0 here. So if a is e, these turn into the same formulas you saw before. The derivative of e to the x is e to the x. The derivative of ln of x is 1 over x. So now we can compute some more derivatives. So let's look at the following examples. Let's say I want you to compute the derivative of the function y equals 2 to the x. What would the derivative be? Well, look at our rule here. What's our value of a? If I look back to my rule, my value of a is 2. So then y prime would be ln of 2 times 2 to the x. And there's my derivative. What about if I asked you the derivative of 2 to the 3x? This one's a little bit harder because of the chain rule. So the inside part is the 3x there. So then y prime would be ln of 2 to the 3x, and then times the derivative of the inside, 3x, which is 3. So this would be ln 2 to the 3x times 3. And there's my derivative. Let's look at one more of these real fast. Or two more of these, sorry. Two more. Let's say my function y is going to be log base 10 now of cosine of x. Well, here I still have a composition, so I'm going to have to use the chain rule. Here's my inside. So y prime 1 over ln. Our a value here is 10, so it'll be ln of 10. And then instead of having x, we have cosine x there, so you'll put cosine x in the denominator times the derivative of cosine of x, which is a negative sine x. So y prime will be negative sine x ln 10 cosine x. Okay, let's look at one final one here. Problem number D. My function is going to be log base 3 of the square root of x over x plus 5. So maybe what we want to do first is rewrite this using our properties of logs, because I have a division here on the inside. I can rewrite my function as log base 3 square root of x minus log base 3 of x plus 5. And then the square root of x here, I can rewrite it as a 1/2 power if I want. So let's go ahead and do that. This will be x to the 1/2. We can use our properties of logs to pull that out in front. Log base 3 of x minus log base 3 of x plus 5. So now I'm ready to compute the derivative, y prime, 1/2. And then a is 3 here, so it's 1 over ln 3 times x minus, and then this one you got to use the chain rule. So 1 over ln 3. And then I have x plus 5 there in my parentheses, times the derivative of the inside, x plus 5. Well, the derivative of x plus 5 is just 1. So here's my derivative now. ln 3 x plus 5. There's my derivative. So I want to end by saying the more you practice the chain rule, the better and better you get at it. So you should practice as much as you can this chain rule on your derivatives.